another fine episode of learning. I'm your host, Miss Lambert, and I hope you're ready to journey with me today through the wonderful world of education. Let us begin with our joke of the day, found at the top right. What type of dogs don't chase cows? Deaf dogs. They never heard anything. That is funny. If you are not laughing, you are dead inside. That is good. And kind of sad, which I think is what makes it funnier. Anyway, so how I want to start, I'm going to split this lesson into 2 videos just so then you don't have a 36-minute video to watch, but I want to break it up more into sections. So, first thing we got going on, well, let me tell you what we're doing in this lesson. We're going to learn how to write the equation of these parabolas given a bunch of different things. So, we're going to start with a flashback to Unit 2 with something called Complete the Square. Some of you are still quite familiar with this because I see your work. You still use Complete the Square to solve equations, and it makes my teacher heart so happy. For the rest of us, maybe it's been a hot minute, so we're just going to review real quick. Big idea with Complete the Square is you are going to create a perfect square trinomial so you can rewrite it as a squared binomial. Here's what I mean by this. If I was to take x plus 5 squared, well, I do not do bad math. I do not kill puppies, so I know that x plus 5 quantity squared, what does it mean to square something? It means to multiply it by itself. So I know that this is x plus 5 times x plus 5. And when I do all my fun distribution, I'm going to get x squared plus 10x plus 25. So this piece over here is what we call the perfect square trinomial because it came from a squared binomial. And so some more examples of this. I know that x plus 3 squared gets me x squared plus 6x plus 9, or x minus, 7 squared gets me x squared minus 14x plus 49. Okay, some important patterns that I want you to see. How do I get from this 6 to that 3? Or that negative 14 to negative 7. Oh, I know that I need to take the b term and divide it by 2. Well, once I have that, how did I get from the number in the factor to the number outside? We're going to take that b over 2, and then we're going to square it. So that's the kind of big thing that we need to remember with this. So here, let's look at some examples. All right, example. We're going to convert an equation to vertex form by completing the square. So here's what we got. We got y equals x squared minus 16x plus 7. And our job is to convert this to vertex form. Well, if vertex form, let's remind ourselves, vertex form is a nice little y equals a times x minus h squared plus k. See how I have this guy being squared? That means I'm going to create a perfect square trinomial, and then we're going to rewrite it as the squared binomial. So here's what I want you to do first, because we're mostly going to be dealing with this part here. So I want you to take this 7, and we're going to start by just moving it to the other side. I call this moving it out of the way. So I get y minus 7 equals x squared minus 16x, and then our job is to fill in the blank. So how do I decide what number goes there to create a perfect square trinomial? Well, like we talked about over here, we take this number in the middle and we divide it by 2, and then we're going to square it to get the other side. So here's what I got. I'm going to do negative 16 divided by 2, and I get negative 8. And now I'm going to take that negative 8 and I'm going to square it, and I get a positive 64. But I cannot just add 64 to one side of an equation. To keep it balanced, we have to add it to both sides. So I'm adding 64 to both sides. And over here, I get y plus, let's see, 57 equals, and now we are going to rewrite this. We have created a perfect square trinomial. I'm going to rewrite it as a squared binomial. So how did we do that? Oh, we take this middle number and we divided it by 2. That's the number that comes into this parentheses. So I get x minus 8 squared. So vertex form, now I just need to move that 57 back over. Out of my way, vertex form. And I get y equals x minus 8 squared minus 57. And that's what it takes. So not too bad, I would say. I mean, I'm hoping that's a little bit easier for you because you're familiar with complete the square. It might have been a hot second since you've used it, but you're at least familiar with it. Let's call that number 1. Let's do another example. Let's go x squared plus 5x minus 10. Okay, same deal. We are mostly just going to be dealing with this, so I'm going to start by moving that 10 over to the other side, just so it gets out of my way. X squared plus 5x blank. Now, normally in this case, we haven't used complete the square when our b term is odd. But guess what? It's the exact same thing, just now I'm going to have a decimal. So to figure out what goes in this blank, I'm going to take my b term, I'm going to divide it by 2, and I know that's 2.5. I'm totally fine if you use decimals. If it asks for a fraction, just type the decimal into your calculator and math frac that thing, and then it turns it into a fraction for you. Now that I have that 2.5, I'm going to square it. I get 6.25, so that comes right there. But I can't just add it to one side, I have to add it to the other to maintain equivalence. So I get y plus 16.25 equals, we're going to rewrite this. Remember this guy right there, once we cut it in half, that's what comes in. So I get x plus 2.5, quantity being squared. And now we're just going to move that 16.25 back over. Lo and behold, vertex form. Okay, like, it's really not different. It just has a decimal. So, same deal. Okay, we're going to move on. And by moving on, I mean we're going to do more examples of completing the square. And you're going, okay, why are we doing more examples? I got this. Because you think you've got it until you see something like this. 2x squared plus 12x minus 13. Okay, convert to vertex form. So I'm still going to move that 13 over. It's still get that out of my way. Okay, what is different here? I have never shown you something where your a value was not equal to 1. And so I want you to be aware that this happens, and it's actually, well, we're just going to learn how to deal with it. Here's what I need you to know. I'm just going to write this down here. If a does not equal 1, factor it out before you create the perfect square trinomial. Here's what this looks like. A does not equal 1. A is 2. So I'm going to begin by factoring out the 2. So I get x squared plus 6x. And now I'm going to create the perfect square trinomial from what is now left inside that parentheses. So I know I'm still going to take this b term and I'm going to cut it in half. And then we got to square it, so I got 3 squared equals 9. So I get a plus 9 here. No big deal. And now you're going, okay, so now we add 9 to the other side. Stop. Collaborate and listen. Sorry, I couldn't resist. Okay, here's what you're going to do. Did I just add 9 to the right side? To the untrained eye, it looks like it, but wait a minute. I didn't just add 9. I really added 2 times 9, which is 18. So I have to make sure to add 18 to the other side to account for that GCF out front. So please remember to distribute that. If you have an A value, that's not 1. You have to distribute it through and then add it to the other side to maintain equivalence. So that's pretty much the only thing that's different. So this becomes y plus 31 equals 2, because now we're going to take this and I get x plus 3 quantity squared, and I'm going to subtract the 31. We get y equals 2 times x plus 3 quantity squared minus 31. Okay, let's look at another example. And this time, maybe just a foreshadow of something you might have to do. Notice how I'm going to put x equals negative y squared plus 18y minus, let's do plus 5. Okay, this time y is being squared. If you remember from last lesson, y squared just means it's going to open, it's a horizontal parabola. If it's a negative y squared, it's going to open to the left. Look at that, we're connecting multiple lessons together. Okay, I would encourage you to pause the video at this moment and just try this on your own before you watch me work through it, just to see how you're doing. So pause it. All right, I moved that out of my way. Now I see that a does not equal 1. A is a negative, and so that counts as something that I have to factor out. So I get y squared minus 18y. Got those parentheses. I'm going to take negative 18 from right there, divide it by 2 to get negative 9, and I'm going to square it to get 81. Now, before I just add 81 to that other side, I need to make sure that I distribute that negative to that 81, and so that becomes a negative 81. X minus 86 equals negative y minus 9 squared. That minus 9 came from dividing that b term, that middle term, by 2. And now we're just going to add the 86. So x equals negative y minus 9 squared plus 86. Okay, and that's completing the square when a does not equal 1. Yeah, you're going to have to do that. So if you have any other questions about that, please feel free to email me, or if you want to sign up for one of my conference call office hours, we can do that. If you want to get a group of you to do that, we could just run through a few examples together. We can totes def do that. Means totally, definitely, in case you're wondering. Okay, one last thing I want to cover in this video specifically. We have vertex form, and the big thing with vertex form is that the single variable is by itself. Well, last time we talked about transformational form. And with transformational form, the squared term is by itself. That's important, so I'm boxing it in red. So for example, let's just pull out an example from what we just did. Let's see. Y equals 2x plus 3 squared minus 31. This is in vertex form because you see how my single variable is by itself, my y. Well, for transformational form, I just need to get the squared term by itself. So with transformational form, I'm actually going to add that 31 back over. So I get y plus 31 equals 2 times x plus 3 quantity squared. I also have to get that 2 out of there because the squared term has to be by itself. And so instead of dividing both sides by 2, we're just going to multiply by a reciprocal. So I'm going to times that, I'm going to do that in a different color, times it by 1/2, whole thing. Because by doing that, those cancel out, and I get 1/2 times y plus 31 equals x plus 3 quantity squared. And that was that transformational form that we talked about last time. If you wanted to remember what format that looked like. I hope you remember what P is. It's the distance between the vertex and the focus or the directrix. Man, you guys are so good at math. Look at you. Okay, so that's just the difference there, is that we would have to get that squared term by itself. I think math space mostly asks you for vertex form, but just in case it asks for transformational form, you know how to do that. And that is where I'm going to stop part 1 of our lesson.